Hello everyone, my name is Mr. Amoyavi and I am one of your grade 12 advanced maths teachers. In our last lesson, we solved a trigonometry question, a typical trigonometry question from the past exam. Now in this lesson, we are going to talk about calculus. Right, calculus, as mentioned before, is one of the topics that many students have issues with according to the survey in the NZD secondary schools. So we are going to look at several calculus questions, and the first question that we have here, if you look at this expression again, the function has got two terms. So we can, just by looking at the expression and the alternatives, we can already exclude some of it and then select the question that is a suitable one. So what I can see, or what I can do here, is to look at the first term. There are two terms in this expression, or the function. The first one is an algebraic expression. The other one is a trig function. So this one, it's easy for me to differentiate using the derivative rule. So, okay, the rule is you bring the exponent in front and multiply by the coefficient, and that will give you the derivative of this term here will give you 6x. So without hesitation, if I have to look at the last alternative, it does not contain 6x. So this option is out. Right? If I look at the third option here, C, it does not contain 6x. So this option is out. So I'm only left with A and B. All right, so I go back to the third one, and I see sine x. Right, according to what we have learned from the rules of differentiation of trig functions, we stated that the derivative of a sine function will give us positive cos x. So with that knowledge, I can say it should be a positive cos x, but here I've got a negative. So I can already exclude this alternative. So the most correct answer that I will have will be A. All right, so we're now going to prove our answer by applying the rules that we have just stated. So if the function is equal to 3x squared plus 3 sine x, right, the derivative, again, if you see expressions separated by a plus or minus, then each of these expressions is called a term, so we can differentiate each of the terms using the rule of differentiation. So the derivative of this function here will be, again, to apply the differentiation rule for this term, it will be bringing the exponent in front, multiply by the coefficient. So it will be 2 times 3 is 6, and then we subtract 1 from this power. So it is 6x raised to the power of 2 minus 1, which is just 1. Plus, as we have predicted, this coefficient here will remain as it is. And then we just apply the rule. If y is equal to sine x, then the derivative of this function, this one will be cos x. All right, so the derivative of sine x is positive cos x. Right, so this is the final answer that we got. So our original guess by using the idea of logic is the correct answer. 6x plus 3 cos x is the correct answer there. Right, so this brings us to the end of a lesson on this question. If y is equal to 3x squared plus 3 sine x, it's a differentiation of an algebraic expression as well as the trig function there. All right, so this brings us to the end of our lesson, and in our next lesson, we are now going to look at the short answer question. But before we do that, we are going to now remove what is on the board here. Hello and welcome back. We are now going to look at a typical exam question on calculus, which will be a short answer question. Right, so the question here reads, given that y is equal to 2x squared plus x, the value of dy over dx at the point x equals 2 is, okay, we have a question. Now, if you're going to read the question carefully, here you will realize that dy over dx is the notation for the derivative or the gradient function of this function. So what you are actually asked to find here is the gradient of this function at point x equals 2. All right, so again, if you want to solve this, the first thing that you need to do is to find the derivative of this function using the rule for differentiation. All right, so the function is y is equal to 2x squared plus x. Now, to find the derivative function or the derived function, you know the rule, we start with the notation dy over dx, which is the notation or the representation of the derived function or the derivative function. So to find the derivative of this function, we bring the exponent in front and then multiply by coefficient here, 2, and then subtract 1 from the power. So if you bring the 2 in front, you get 2 times 2 gives us 4. And then minus 1 from this power, it will be x raised to the power of 1. Plus, bring the 1 in front. This is x raised to the power of 1, so 1 in front. Multiply by 1, it will be 1. Subtract 1 from this, it will be x raised to the power of 0. So it is actually 1. Anything raised to the power of 0 is always 1. So this is the derived function or the gradient function. So in order to find the gradient of this function at x equals 2, all you have to do is you substitute this 2 into this function. So therefore, the derivative or the gradient of this function at point x equals 2 will be 4 multiplied by 2 plus 1. So we get 4 times 2 is 8, 8 plus 1 is 9. All right, so the derivative of the function at point x equals 2 is 9. So what we have actually done is, in order to answer questions like this, if you're asked to find a gradient of a curve or of a function at a point, you firstly find the derivative function, like what we have done, and then you substitute that value of x into the gradient or the derived function. And once you evaluate that expression, then you get the gradient of that function at that point. Right. This brings us to the end of our lesson on the short answer question. In our next lesson, since calculus is an important subject, as we have mentioned, it's a topic where a lot of students face problems. So in our next lesson, we will answer another 2 questions, 1 multiple choice question and a short answer question. Thank you, everyone.